For our final lesson in the trig unit, we're going to do a consolidation of all of the different tools that you've learned about as they apply to triangles and solving for unknown angles and sides. So I'd like to begin by just looking at what we know we can use for all triangles of all types. And the one rule that we know about for all triangles of all types, regardless of whether they are right triangles and where they have a 90-degree angle in them, or if they are acute, in which all angles are less than 90, or obtuse, where there is one angle that is greater than 90 degrees, and the combination of these, by the way, are called oblique triangles. We know that all triangles have this rule, that angle A plus angle B plus angle C is equal to 180 degrees, or whatever letter designations you have for the vertices of that triangle. So that is true for all triangles regardless of their type. What we want to do now is look at the tools we've learned about in this unit that are unique to right triangles or to oblique triangles. So when you're given a problem, you know that you have this tool that works for all triangles. The first question to ask yourself is it a right triangle or is it oblique? So let's look at all the tools that you know about for right triangles first. When it comes to right triangles, the one tool you came into this unit with is the idea that the sides of a rectangle where there's a right angle have a relationship with each other. And that is that the legs of the triangle, the two shorter sides, when they are squared first and then added together, are equal to the square of the hypotenuse. And some of you might be used to seeing the Pythagorean theorem written this way, or you might also be used to seeing it as this. It's where instead of using the letter C, we use the letter H for hypotenuse. Okay? So Pythagorean theorem is great for these scenarios, but there's no connection at all to the angles inside that right angle triangle. So the first thing that you learned about in this unit in terms of how to solve for unknown angles in right angle triangles is you learned about the primary trig ratios. And those primary trigonometry ratios can be remembered using this really cool little acronym called SOHCAHTOA, where S stands for the sine of an angle in that right angle triangle is equal to its opposite side length over its hypotenuse. The cosine of an angle in a right angle triangle is equal to its adjacent over its hypotenuse. And the tangent of an angle in that right triangle is equal to its opposite side length over its adjacent side length. So those are the two tools that you have to work with for right angle triangles. And again, we're getting away from this one because it has very limited usage, and we really did focus on these ones because they are slick and quick, especially with right triangles. This is what we looked at essentially in Chapter 7. And this is the focus of Chapter 7. Then we moved on to looking at oblique triangles. And how can we solve for missing side lengths and angles in these types of triangles? And we learned that the tools from this chapter can be used for right triangles, but they're a lot more lengthy and involved. So we prefer to keep these to our right triangle friends. So when you get to an oblique triangle, the first thing you need to ask yourself then is, what is given in the triangle to help decide which tool to use? What's given? What are you trying to find? So the first scenario that we looked at in this unit is, what if you are given an opposite angle side pairing? Meaning you have a triangle and you know an angle and its opposite side like this. Okay? And on top of that, you are given one other side or angle length. So 3 pieces of information altogether. Then you can use what we've learned is the sine law. And the sine law can be used a couple of different ways depending what you're solving for. If you're solving for a side, because the other piece that's given is its opposite angle, then you might use 2 of these proportions to solve for a side. And we can put the side we're solving for in the top left to make rearranging the equation easier. So you don't have to have all 3 of these. You only need to use a pair of them because you're given 3 pieces of information, boom, 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 for example, and you solve for the 4th one. If what you're trying to solve for is an angle because you're given a side as your 3rd piece of information, then you might use it this way instead, where the sine values of the angles are in the numerators and these opposite side lengths are in the denominators. So there's 2 ways to use the sine law. All right, if in the triangle you're given you see information that I like to call SAS, meaning you have a triangle and you are given a side, angle, side, meaning 2 sides and the angle in between them, then you can use something called the cosine law. And one of the versions of this cosine law deals with finding the 3rd side because the other 3 things are given. So let me show you what I mean. A simple version could be a squared is equal to, remember we developed this pattern, cosine A here, where this angle is given between the 2 other sides. We can fill in those 2 other sides like this. So again, we would use this version of the sine law when we're solving for a side length. We know 2 of them and the angle in between them. Okay. Finally, the other scenario we might be given in an oblique triangle is where we know all 3 sides and no angles. We call that S. And again, we can use the cosine law to help us. This version of the cosine law, which is really this one just rearranged without going into all the details, means that we have to start by solving for one of the angles. Let's say I solve for angle A. I have to be given all of the other 3 side lengths. I have to be given the side length opposite the angle I'm solving for, and I'd have to be given the other 2 sides as well. And there you go. The pathway that you follow will be dependent on what you are given in the question. And my hope is that this flowchart will help you to see the relationship between the individual skills that you've been learning about throughout the unit, such that when you get to a summative assessment, you know exactly which tool to use by asking these questions to yourself. Do I have a right angle or an oblique? If it's oblique, what am I given? And that tells me whether to use sine law, cosine law version 1, or cosine law version 2. All right, good luck with your summative practice. And again, let me know if you have any questions along the way.